13.7, and so this is the last section in calculus 3, and it's about the divergence theorem. Sometimes we call this divergence theorem as the Gauss theorem. So basically we use divergence theorem to convert a flux integral over a closed surface into a volume integral. Let's state the divergence theorem. So, divergence theorem. So we have a boundary of a solid. So let's say let S be a closed surface. We have a closed surface oriented by the outward pointing normal to the three-dimensional region E. So here is the picture. We have a three-dimensional region E in R3, and the boundary of the solid is S. So S is the boundary of the solid. That's your S. Okay. And we have an outward pointing normal vector end, and on this closed surface we have a vector field F. Okay. Now if our vector field F is a continuously differentiable vector field defined on A. So we have this vector field F over the solid domain E. Then flux integral F dot ds over the closed surface S. This is the way we denote a closed surface. The flux integral over the closed surface S equals to the integral of the divergence, triple integral of the divergence of F over the domain E. And we know that divergence of F equals to gradient dot F. And so this is the way we define the divergence theorem. So basically this flux integral over the closed surface S equals to the triple integral of the divergence of the vector field F. So this is the way we define the divergence theorem. Now